Alright, so this is some help for 6.3. One of the homework problems you have to do is number 3. They give you f of x and they give you g of x. And you're asked to solve for f of x plus g of x. So all we're going to do is we're going to add f of x to g of x. So what that becomes is f of x, which is negative 3x to the 1/3 plus 4x to the 1/2. Plus g of x, which is 5x to the 1/3 plus 4x to the 1/2. Now what we have to do is decide if we can combine like terms to simplify that answer. And if you recall, we cannot combine these x terms unless they have the same exponent. So this one and this one are both x to the 1/2. We can combine those. 4x to the 1/2 plus 4x to the 1/2 becomes 8x to the 1/2. We just add those coefficients. We have negative 3x to the 1/3 and positive 5x to the 1/3. We can add those coefficients, or in reality we're subtracting 5 minus 3, and we're getting 2x to the 1/3. And that's as far as we can go, because once we have different exponents, they're no longer like terms, and therefore they cannot be combined. Now in terms of domain, you look at each function individually, f of x and g of x, and you say, are there any restrictions on x? Well, when you have an even root, x cannot be 0 or negative. You cannot have a negative square root, because remember, x to the 1/2 is the same as the square root of x. And we cannot have square roots of negative numbers. So for f of x, it's okay for x to be all reals except 0. Okay? I'm sorry, or except negative numbers, my mistake. We cannot have any negative values for x because there's a square root there. So basically it's all reals where x is greater than or equal to 0. That's the valid range. For g of x, we have the same situation. We have the square root of x, which is x to the 1/2. And so the domain of g of x is all reals where x is also greater than or equal to 0. Once we establish the domain on f of x and g of x, then we can find their overlapping piece. And in fact, since the domains are the same between f of x and g of x, then the domain of the solution is therefore the same, all reals where x is greater than or equal to 0. Let's do another one. Let's do number 19. I will do 17 actually. F of x equals 4x to the 2/3. G of x equals 5x to the 1/2. And in number 17, we're going to do g of x over f of x. Alright, well g of x is 5x to the 1/2. F of x is 4x to the 2/3. 5 over 4 cannot be simplified. We have x to the 1/2 over x to the 2/3. We subtract our exponents. 1/2 minus 2/3. That's the same thing as 3/6 minus 4/6, which is negative 1/6. So it's x to the negative 1/6. But we don't like to have negative exponents in our answer, so we move the x to the negative 1/6 to the denominator as positive. And therefore it's 5 over 4x to the 1/6. Now as far as domain goes, we look at the f of x. The domain of f of x, okay, this is a cube root. X to the 2/3 is the cube root. There is no restriction on a cube root. We can have a cube root of a negative number. So for f of x, it's going to be all reals. For g of x, we have a square root. We cannot have negative numbers under the radical. We cannot have negative square root. So for g of x, it's all reals where x is greater than or equal to 0. We then look at our answer, which is right here. Are there any additional restrictions? Yes, we cannot create 0 in the denominator. X cannot be 0, because if x were 0, we would be having 5 divided by 0, which is undefined. So what we do is we look at the intersection, and the domain of f of x is all reals. So we'll draw a squiggly line there. For g of x, it's all reals where x is greater than or equal to 0. So that's the g of x piece. And then for the answer, we determine x can't be, we do not allow 0. This is out. So the intersection of all three pieces is the domain of our answer, which is all reals, where x is now greater than 0. So anything 0 or less is invalid. I know that sounds a bit complicated. I'll review it again, but hopefully this is enough to get you started.